Welcome to College Algebra Through Modeling. This is a course that is very data-driven, and so most of the examples that we do will be driven by actual physical things. Data can be anything from population, temperature, shoe sizes, ages of people, and so forth. So the first thing that we will talk about is one variable data. And in that, what is actually going to be important is if you take one variable data, like you look at populations of cities or populations of cities in a specific state, for example, then you can extrapolate from that information about the state, right? So one of the things that we would look at is an average, because the average, as you probably are already aware, is giving you a feel for what those numbers mean overall. An average is telling you that, this is the average, this is the middle ground, effectively, based on the populations of all of the cities. This would be the average population of a city in the specified state. So, to give you a specific example, let's look at some data. So here's population data for a number of cities in Colorado. Specifically, these are all cities that have populations over 100,000. So I'm assuming that a city means it has a population over 100,000. In this list, we have Denver, Boulder, Colorado Springs, Fort Collins, Centennial, Aurora, Arvada, Lakewood, Pueblo, Thornton, and Westminster. Now, if we want to approximate the average population of these cities, what we will do is add them all up and then divide by the number of cities that we have. So the sum of them all is 2,445,630, and we have 11 cities. So we take the sum and we then divide it by our 11 cities. This gives us an average of 222,330 as the average population of a larger city in Colorado. The second thing to discuss for one variable data is a median. Now, a median is sort of like the middle. And in order to talk about the median, you have to look back at the data that we have. And usually how we would do this is by ordering the data, usually from a minimum to a maximum, in order to determine where the median is. So here are the cities reordered based on the minimum to the maximum population. And in terms of the median, we're looking for the middle number, basically. So if this is the minimum, this is the maximum, I can effectively take off down until I get to the middle number. And the middle number, in this case, happens to be Thornton at 130,307. Now notice that the 130,307 is significantly less than 222,330, right? 222,330. Now, why is that the case? This is why we look at an average and a median. So the median is telling you the middle number, which by being the middle number at 130,307, it's telling us that there are a lot more cities with a lower population than there are with the higher populations. So, right, Denver has 663,000, nearly 664,000 people, and all of these other ones are in the 100,000s, right? There's only 2 other cities that are above 200,000. And so when our average is 222,000 and our median is 130,000, it's telling us that there are a couple cities with populations much, much larger than the rest of them, but that is what's bringing our average value up. The median is still only 130,000 for these cities, which means that most of the cities that we're looking at are in the 100,000 range. Which, right, as you can see just by looking at the data, Most of these numbers are in the 100,000 range. Now, a question that you may be considering is, what if I only have, like in this case we had 11 cities, so the median was very easy, it was the middle. But what happens when the data is even? Like I have 10 cities instead of 11 cities. So for simplicity, I will just cross off Denver as being, that one's the largest. So we'll say, if we ignored Denver for a moment and we wanted to find the median for the surrounding cities, then again we could tick off, right? But what we would find is that we end up with 2 in the middle. We have Arvada and we have Thornton. So then what is the median here? There's no middle number. There's 2 middle numbers. So in order to do that, we have to look at the average of these middle 2 numbers, which I'm going to change colors. Hold on. So I'm looking specifically at these 2, and then I take the average of those middle numbers. So if we add those 2 middle cities together, we end up with 243,881. To take the average, we would then divide that by 2. There's 2 cities, we divide by 2, getting us 121,940.5. Question, does 0.5 make sense in terms of the number of people? Not really. So generally speaking, if you were talking about something like the number of people, a 0.5 is not particularly useful, right? All of this has to come back to something physical. So in general, what I would do is take this and round down, because from 0.01 to 0.5 we would round down, and well, 0.00001, however far out it goes. So if it's anything over the number up to 0.5, we round down. If it's beyond 0.5 at all, so it could be 0.5000001, and that would allow us to then round up to the next number. So in this case, we would round down to say that we have an approximate median of 121,940 people. Now, this is important. If it's people, we have to round. If this had been, say, income, then the 0.5 would correspond to 50 cents. That's not something that isn't physically relevant, right? 50 cents is 50 cents. It exists. A half a person isn't usually counted in a population. So it does make some difference to be aware of what you were talking about. The last thing for us to talk about is 2 variable data. And what we will specifically be looking at with 2 variable data is relationships between the 2 variables. So if we talk about the population of these cities and then we look at the population density of these cities, is this something that we expect to be related or not? So here's some data on the population density of each of these cities. And I kept them in the order that we ordered them in, which was the least population to the highest population. And as you can see, is there a correlation between the lower population and having a lower population density? The answer is no, actually, in this case. Now, you would expect one, right? If there's more people, the city is going to have more people crammed into each square mile. But if you look at it, Denver and Boulder are actually very close, and Boulder had the lowest population and Denver had the highest population. So the thing that we're not taking into account in this measurement in order to determine if there is a correlation is the actual size of the city itself. And so part of the reason for Boulder to have so much such a higher population density is based upon the size of Boulder. Now, the size of Denver is quite large, but so is its population, whereas the size of Boulder is quite small, even though its population is large, but nowhere near the size of Denver. So this is important information. Now, if you notice that the numbers increase in the same order that they increase for population, then there's obviously a correlation there. But in this case, it just doesn't seem to hold. The lowest population density is in Pueblo, but if you look at Aurora and Colorado Springs, they're not that much higher, right? So this is interesting stuff we'll expand upon in class. please let me know if you have any questions.